Fine, guys. So now if you want to see the practical application, okay, of PDF and CDF, so we need to go to the let's take example of a iris data set. Okay, now iris data set, so in machine learning, right, so you have lots of data sets, and so there will be some basic data sets which like everybody will be using. So after that we will be using some unique data sets and advanced data sets. Okay, but initially I would say most of the people will be working on Titanic data set or iris data set, okay, or wine quality, etc., some basics, common data sets, and one of those data sets is the iris data set. Now what is this iris? I'll just give you a idea about this iris data set. Okay, iris um, mm, yeah, and I think I already have. Do we have the iris? Okay, I don't know. Fine. This should be good. Okay, now if you see this see guys, this flower is called iris flower. Okay, this flower is called iris flower. In this what happens is there are three types of flowers, but initially before coming to that, see, if you observe this flower, okay, if you observe this flower, there are two types of leaves. Okay, there are two types of leaves. One are this big one, agree, this big one and this big one. Okay, and one are this small one. Are you able to see? Right? One is a big one and one is a small one. Fine. So these big ones are called sepals. Okay. These big ones are called sepals. Okay. See, understand this because we will be using this data set in our machine learning problems also. Okay. So this big one is also called sepals. This small one is also are called petals. Okay. Same thing. These big ones are sepals. The small ones are petals. Okay. Sepals, petals. Fine. So now one person, okay, one person, what he did is he has observed lots and lots of iris flowers, okay, and he noticed that even though all of these, even though all of these are iris flowers, but there is some difference between the shapes of the sepals and petals between different types. For example, if you see this iris setosa, okay, iris setosa, this sepal is different from what you are seeing from versicolor setosa. Sorry, versicolor sepal. Agree? This sepal is different from this sepal. And this sepal is looking different from this sepal. Agree? So after observing lots and lots and like random flowers, so he thought why we should not use, why we should not use some machine learning algorithm, okay, to segregate this. Okay. Now here you need to understand four things. This is the red. This one is sepal. Now once this is sepal, this is called as this length. Okay, this length is called as sepal length. Okay, this length is called sepal width. Okay, guys, and the small one, this is called, okay, the horizontal part is called petal length. Okay, and this is called petal width. Fine. Same thing. This is petal length. Okay, this for versicolor and this is petal width for versicolor. And for this This is called sepal width, sepal length. Same thing. Fine. So you have four measurements for each flower. Okay. For each flower, you have four measurements: sepal length, sepal width, petal length, petal width. Okay. These four measurements he has observed. Okay. He has observed, and after observing like tons of examples, he understood there are some differences. All are not same. All these measurements are not same. So that means there is not only one type of iris flower. There are different types of iris flower. Okay. He don't know at that time. He don't know whether three types or four types. But after that, once we use machine learning algorithm to segregate them, we are able to get three types of flowers. We named it as Setosa, versicolor, virginica. Okay. Where it will have its set of sepal petal lengths. It will have its own. It will have its own. Okay. So, but ideally, there are four measurements what you need to understand, and there are four categories. Output categories are, sorry, three. Okay, three categories, three types of flowers. In each flower, it is having four measurements: sepal length, sepal width, petal length, petal width. Let me know. Is this clear? Is the flower details clear?
Yes, Santosh.
Okay, fine. So once you have this flower, now, okay, we are not discussing the machine learning part, but I'll just give you an idea. So if at all someone tell you, hey, my sepal length is some, for example, okay, before that I'll show you the data set, then you will have some idea. Okay. Yeah. See guys, see, this is a, okay, see, this is a set of points. Okay, there are four. If you understand the data frame, what does this have? This is having four features. What are the features? Sepal length, sepal width, petal length, petal width. Okay. And what is this variety? Variety is the output column. Okay. What is the flower name? Okay. So this four will constitute one flower. Okay. If you have these four measurements, you will have one flower details. Okay. So for Setosa, see, there are like, initially there are all setosas. Okay. And if you see somewhere in the middle you have versicolor. Okay. And again at the bottom you have virginica. Okay. So there are total how many? Yeah, total 150 flowers you are having. Okay. Out of this 150 flowers, so roughly you are having 50 setosa, 50 versicolor, 50 virginica. And each flower will have its own four parameters. Okay. It's have its own four parameters. So now if I just tell you, okay, now if I just tell you, hey, my values are like, let's say 4, 4.5, 5, 5.5. Okay. That means what? Sepal length, sepal width, petal width are these. So can you tell me what type of flower this could belong to? Okay. If that is a question we are having. So when we study the machine learning algorithms, so at that time we are going to see the complete detail, like how, which algorithm to use, how you can, you know, train and test everything. But now here our point of interest is to use the PDF and CDF, which we have studied yesterday. Okay. And apply those to this data set and understand some practical application of this. Okay. So now I hope you understood the data set. Fine. So you're able to understand the data set. So this is, I have loaded the data set pd.read CSV. Okay. This command will load the data set. And this is the data set. Fine. So now if I want to, the point here is, if I want to find out which column are very important in classifying the given data point into a setosa, versicolor, or virginica. Okay, see, observe my words again. There are four columns, guys. There are four columns. Okay, if at all, if the question is, out of these four columns, okay, out of these four columns, if at all, if you want to choose only one column or maximum two columns, okay, what columns would you choose so that you will have better classification of output variable? Okay, better classification of output variable. This could be interview question. Okay, so I don't want to do the classification. Okay, that's different. But just by looking at the data set, okay, just by looking at these four features, okay, these are all features. Okay, all this is machine learning terminology, which we'll be learning once we go there. Okay, but all these are called as inputs, you can call as of now, okay, or input columns or features. Okay, so out of these four features, can you tell me which one are more important, most important? Okay, which one are the least important? Okay, in what is our goal? Our goal is to classify the given data point into one of the three output classes: Setosa, versicolor, virginica. Okay, that is our goal. And the question is how you can choose. Okay, and to be very specific, how you can choose and use the concept of PDF and CDF and decide which column you should choose among these four, so that it will be better for us to classify the given data point into one of the three output classes. Okay, is the question and goal clear, guys? If it is clear, then I will move forward and show you something interesting. Is question clear for everyone?
Yeah, Santosh. I mean, out of these four, which features, I mean, which two features by selecting you can, we need to tell, right? Out of these four, which two we need to
Correct.
use
Correct.
to select.
Which feature is helping
Yeah.
us more in the
No.
classification? Okay.
Mm.
So for that, yesterday, okay, so we have seen KDE, right? Kernel density estimation. We have seen KDE. If I just go back, okay, kernel density estimation, this concept we have seen, if we have seen, right? So it will, how it will draw the graph. Okay, it will do certain estimations, etc. Now here, as I said yesterday, you don't need to do that manually. Here you have inbuilt Seaborn. Okay, you know Seaborn. We will be studying in the visualization concept, but Seaborn is also one of the plotting library. Okay, usually we import it as SNS. Okay, so no SNS. Now inside that Seaborn, okay, you have something called as KDE plot, guys, kernel density estimation plot. Okay, so you will use that plot, and data frame, what we are passing, my data frame is DF. Okay, I'm passing that. And initially I want to do the kernel density estimation of my petal length. Okay, so that's why X is my petal length. Okay, okay, fine. Let's see only till petal length. Okay, we'll see the hue parameter later. Okay, now, first of all, if I just okay, see guys, for petal length, this is the kernel density estimation which it has done. Okay, so yesterday we have done it manually, right? So given all the data points, if you plot and if you start considering each as the mean and considering some standard deviation, we are able to draw the graph, right? Similarly, for these values, what is this sepal length? Okay, uh, see, focus here. For the sepal length, that means for these values, kernel density estimation has given us this plot. Okay, that means what? The values are ranging. The values are ranging from what is this, guys? I can say 2 to maximum something less than 9, and these are the frequencies. Okay, density frequencies, and somewhere around like 5.5 or 6.6, you are able to see maximum frequency of the values. Agree? Right? So for the sepal, this sepal length, right? So this is sepal length. So if I just take this column, only single column, and if I put it over here, and if I try to sort it from smallest number, okay, so it is starting from 4.3, 7.9. The smallest value should be what from the sepal length? Okay, I think the first, okay, I think from starting over here, it is taking, okay, but that's fine. But the starting values are this, okay? The minimum value or maximum values are this, okay? But the kernel density plot is this, okay? Here, here, is it looking like normal distribution, guys? Can someone say me?
Yes, Santosh.
Right? Fine. So that is one estimation. But most importantly, if you see, this is a sepal length. Okay. But our goal is what? Our goal is what? Our goal is using this column, we want to divide it into, oh, sorry, we want to predict the output category. Okay. Like how much this sepal length will help us in predicting the output category as setosa, versicolor or virginica. Agree? So that means what? See, you can have, so here in setosa also, here in setosa, you can do this. Okay, that means what? What I'm doing? I'm saying DF of variety equal to setosa. Okay, only in setosa. Okay, only in setosa. See, if I do this, try to understand. Yeah. So what did I get? I got only where the variety equal to setosa. Okay, I got only that column, guys. Okay, I got only that column. Inside this, again, you will have four values. These are all the values of the setosa, four values. Here, if I take only sepal length, okay, these are the sepal lengths of all the setosa flowers. Agree? These are all the sepal length values of the setosa flower. Agree? Similarly, you'll also have versicolor and virginica. If I give it as virginica, what are these? These are all the values of sepal length where the flower is virginica. Agree? So what I'm saying here is, if you consider sepal length, okay, if you consider only sepal length, okay, and if you want to, you know, try to understand like how it is impacting the output column, you should also draw the plot in a combination of both sepal length and how its contribution in the variety. Further, you need to use the hue parameter. Okay. So if you say SNS dot KDE plot, okay, this is my data frame, and I want to plot sepal length, okay, but basis on what? Variety. That is hue. Okay, basis on variety column, like based upon that column, how my sepal length is splitting. Okay, if you want to see that, okay, you need to give that as a hue parameter. Okay, if you want to plot only sepal length, that's fine. Okay, all sepal length, this is for all sepal length. Okay, but if you want to divide it into based upon the variety column, okay, you need to do this. Okay, once you run this, you got this. So okay, so these are the sepal lengths. Okay, all these are sepal lengths, but for three different flowers. Blue is for setosa, this orange is for versicolor, green is for virginica. Okay, so for setosa, this is the distribution. For versicolor, this is the distribution. For virginica, this is the distribution. Agree, guys?
Yeah, Santosh. In the above, we got uh,
This is only sepal length for all the flowers, not
sepal
any flower.
for everything. Yeah.
Right.
Now we
That
have
means
variety,
the
three
whole thing.
flavors, three different.
Correct. This is for the whole flower. But if you want to also see flower level, okay, for only setosa, the sepal length is this. Only versicolor, the sepal length is this. Only virginica, the sepal distribution is this. That means what? If you want to draw it for only setosa, first of all, you should find out all the sepal length for only setosa flower. So that's why I have shown you this. If you do this, okay, see, if I do this, okay, that means what? I am taking from the data frame. See, the way how you need to understand is this, you know in the pandas, but I will explain you. See, first understand, okay, first remove this sepal length, okay. First of all, you need to consider, take only the setosa column, filter it on the setosa on the variety. So that's why what I'm doing, DF of variety, okay. That means what? DF is a data frame and inside the column is variety, okay. Where DF and inside this variety column is equal to setosa, okay. I want to take that. Sir, you did not mention any color related to variety, how it is showing. Yes, Rish, I'll come to that. Just give me a second. Okay. So DF of variety is setosa. Okay, DF of variety equal to setosa. I'm taking, and I should inside DF I want to do that. Okay, inside DF I want to filter on this condition. Okay, if I do that, I got what? All setosas, only setosas. Okay, 49, 0 to 49. That means 50 setosas are extracted. Okay, only setosas. In setosas, you are having four parameters: sepal length, sepal width, petal length, petal width. Now, in this data frame, that means in this data frame, if I want to see only sepal length, give over here only sepal length. Okay, then it will show you only sepal length. Okay, this is the sepal length of setosa, and this is having some values, and obviously this will have some what? This will have some distribution. That distribution is blue color. Setosa sepal length. Clear? Similarly, if you take the versicolor or virginica, for example, if I take virginica, now the values which you are going to see here are, these are all the sepal lengths of virginica flower. Okay, all these values, and the same thing is the virginica green color. This green color is the virginica sepal length. Okay, and Sirisha, the flowers will come out. The colors are automatic. So if you are plotting three, so it will give some random three different colors. You can also use some parameters over here, but if you don't use, by default, it will give three different colors. Okay, but is the plotting clear, guys? Are you able to understand this graphs, three individual, how it was able to plot this?
Yeah, Santosh.
Everyone?
Yes, sir.
Okay, fine, simple. So because we not go study like pandas and plotting, right? So that's why I'm explaining in bit detail, but it's doing very simple thing. So you are passing the data frame. I want to have the sepal length. Only sepal length means it will plot. It will not worry about what type of variety you are asking. Just take this column sepal length and just plot it. Do the KDE. But here you're also splitting it. You're also splitting it on the you're also splitting it on the particular column. If you want to split it, you need to mention it on the hue parameter. Okay. So see, Sirisha, hue is, I want sepal length, but based upon the hue. That means in hue, that means what? In hue, I'm giving variety. That means in variety, first it will go to variety. In variety, what all it is having? Setosa, versicolor, virginica. Now, based upon this hue, it will try to show you the sepal length. Okay, it will not show you the simple, the plain sepal length as above. It will show for setosa, how many sepal length are there? For versicolor, how many sepal length? Okay, again from virginica, how many sepal length? Okay, that one. So if you want to show the given input column on basis of another column, okay, that another column you should give it in the hue. Okay, so that's fine. So this is one. Similarly, you can just draw sepal width, petal width, all basis on the this variety. Okay, see, I'm drawing sepal width. Okay, here I am done with sepal length. Okay, guys. So I'm drawing sepal width. Okay, see, if I want to draw it again, so I'll just run it and show you. Okay, see, you got sepal length. Okay, now if I run it, sepal width I got, same thing, hue variety. Now petal length. Okay, these are petal length. Okay, and these are petal width. Okay, these are petal width. Okay, so now you are having four graphs. Okay, you are having four graphs. Fine. So now, can I put all four at one place that you will easily understand? I'll try this. Just give me a second. So I'll try to put all four over one place so that it will be easy for you guys to understand. If I do this small, is it visible? Just give me a second, guys. I'm trying to put all at one place. I don't think that's happening. It's not happening, guys. Okay, sorry. Fine. But I will try to explain you here itself. See, guys. Now, these are the four distributions you are having. See, observe this. 1 second. Observe this. Observe this. Now observe this. Okay. Now, based upon what we have done, guys, we have just used the concept of, okay, we have just used the concept of PDF. Okay, we just use the concept of PDF. And what is inside PDF? The concept we have used is kernel density estimation. Using that same kernel density estimation plot, we are able to plot this. Okay, we got 4 graphs. Okay, now see, it's interesting. Now our aim is just looking at these graphs, using this KDE plots, you should able to tell which column or which 2 columns you would go ahead. Okay, and what is our goal? Our goal is to classify the given data into Setosa, Vertical, Virginica. Fine, that's fine. But here, if you try to understand these graphs, see here. If I tell you, the point is this, okay? So if I tell you the sepal length is, okay, 5. Okay, if I tell you sepal length equal to 5, fine. What you will do? Plot here 5. If sepal length is 5, what are the possibilities that the flower could be, guys? Tell me. Be interactive so that you will understand it better. So if I tell you 5, what are the possibilities that the flower could be? Just by looking at the graph, guys. So this is 5. See, what is this graph is saying? This blue color graph is saying these are the distribution of sepal length where the output type is Setosa. Getting? That means what? It is ranging from around some 4 to some 6. Okay, the Setosa sepal lengths are. And versicolor sepal lengths are ranging from just above 4, like for some 4.2 or 3 to till what? 7 point something. Okay. And Virginica sepal lengths are ranging around same point, and it is going till some around 8.8 or something. Okay. These are the values it is saying. So now if I just tell you sepal length equal to 5, which is over here, can you guess like what type the flower could be?
No, it can be any of the 3.
It can be any of the 3. No. Because if I just draw a line, horizontal line over here, okay, sorry, something here, it is touching all the 3, right? It could be this, it could be this, it could be that. Fine. Now if I say the value is, okay, if I say the value is 7, what it could be, guys?
Both Virginica and versicolor.
Right? If it is Virginica, it could be versicolor and Virginica. Fine. Similarly, if I say it is 8.8, it could be
Only Virginica.
only Virginica. Okay. Fine. So that's how you need to understand this. Okay. But if I say, if I give you some value between this particular part, fine. So there is much overlapping, right? Here, okay, at least okay. In here it is fine, but here mostly from here to here, okay, there is much overlapping. Agree? So if you see from here to, yeah, here. So if you take any value, so that will have 3 points over here. Okay. So that means what? You cannot directly tell what flower it belongs to. Fine. And our fundamental goal is, which is the most useful column. That means if I just tell you, hey, my sepal length is 6, you should be able to tell me, hey, if your sepal length is 6, the output flower should be setosa. It cannot be any other flower. If you can confidently say that, then that column is more helpful, or it is most important one. Agree? But if you are in a dilemma, hey, it could be setosa, it could be versicolor, then obviously that's not helping much, right? Agree?
Yes.
So that is a story with the sepal length. But if I come over here, if you see sepal width, okay, if you try to see sepal width, here also there are lot many overlappings. Agree? See,
Yes.
if I tell you some value over here, okay, so obviously it could be anything. It could be this, it could be this, it could be this. Fine. Even here, 3 also, it could be any of these. 3.5 also, any of this. Fine. Are you understanding, guys? If someone says you, hey, my sepal width is 3.5, okay, for example, if it's 3.5, you are not in a position to exactly tell what type of flower that could belong to. Fine. Because if I have 3.5, you can see there is some orange versicolor also having 3.5, and here there is some virginic also having 3.5. Here some setosa is also having 3.5. Fine. You're not having 100% confidence just by the sepal width in some areas. Okay, almost in all these areas, almost in all these areas. Fine. Just by if someone gives you sepal width, you're not able to say. You're not able to categorize that into one of the output type. So obviously this column is not helping much, right? You guys able to understand?
Yes, Santosh.
Right. But if you go to other column, see this. If you see this column, petal length, it is very much helpful. As you can clearly see, setosa petal length is completely separated from other two.
Yes.
Right? So we did not do anything. We did not apply machine learning. We did not apply any tools. We did not use any library, nothing. We just took the column. We just applied KDE plot, which uses PDF concept. Okay. And using that, if you observe just with your eyes, you are able to see the petal length of this blue color, that is setosa, are clearly separated from other two. Okay. So if I tell you 1.5, petal length is 1.5. Can you tell me what is a flower?
Setosa.
Okay. How much confidence?
Because that is the only one which is present
Correct.
from
I'm
1
asking
to
what is a percentage confidence level? With how much confidence you can say?
100%.
Right. So because if you see 1.5, there are no overlappings over here. Fine. Till 2 or till this range, there are no overlappings. Fine. So at least to certain limit, okay, you can be 100% confident. Okay. At least you can make from 3, you can make it into 2. That means you can say, if, for example, simply you can say, if petal length, okay, if petal length is less than 2, okay, if this is 2.1, for example, less than 2.1 and greater than what, 0.8, for example. Okay, if I write this, where petal length is between 0.8 to 2.1, okay, clearly this will become setosa. Understanding? That means, obviously, you got a clear output category. Here, there is no dilemma. Fine. Anybody gives you, and also you don't want any other measures also. That is important. Fine. You don't want it. That means what? You don't want, if you have this particular value, petal length, okay, you don't want sepal width, okay, or sepal length also, because with the help of just petal length, you are able to segregate the setosa flowers. That means if someone says you, hey, my petal length equal to 0.6, is this falling in this range? Yes, it is falling in this range. That's it. You don't need any much more information. Okay, you can just say, because petal length is 0.6, your flower will be definitely setosa. Your flower will be definitely setosa, because the petal length of setosa flowers are very much separated from the other two. Okay, so with the petal length, you are able to get clear classification at least to one level. Okay, still versicolor and virginica, there is some overlap, but at least one level, one flower, you can simply separate it out. Okay, is it helpful? Did you get it?
Yes.
Just by analyzing the graphs. Okay, just by analyzing the graphs, you are able to segregate it. You can just separate all the setosa flowers. Okay, so if someone gave you, okay, just as a random experiment, if someone gave you actual flowers, actual setosa flowers, 100 flowers they have given you, okay, that means what? The flowers will look like this, right? So these flowers, okay, you can just take a scale as an example and measure this petal length. Okay, what is this petal length, guys? Okay, what is the petal length for this small one you are able to see, right? So this one, so this one, these are all petals. Okay, the small ones are petals. Okay, these petal lengths, okay, you can measure, fine. And if at all that is falling between this range, okay, minus 0.8 to 2.1, okay, you can simply put out that flower as setosa. You don't need to check anything more. Fine. With the help of one single measurement, you can just put it out as setosa flowers, and the remaining left will be versicolor or virginica. Okay, fine. So we understood that petal length is helpful, and this is how you can use KDE plot. Okay, and also if you see the petal width, okay, if we see the petal width, this is also working fine. Okay, this is also working fine. Petal width also giving you decent separation for the setosa flowers. Okay, and for versicolor and virginica, there is some overlap. Okay, but at least for setosa, you can see a clear separation. Okay, so petal width is also helping us. Fine. So now, if at all you want to choose, okay, if at all you want to choose two columns from this, what two columns you are going to choose, guys? You're having sepal length, you're having sepal width, you're having petal length, you're having petal width.
You mean apart from variety?
No, man, I'm asking out of these four columns, if at all you want, what is our main goal before we started this? What was our requirement? From these four columns,
I have to select two.
choose two columns, okay, which will help you maximum in segregating this, in for example, in predicting or categorizing them into this output. Okay, so out of these four columns, which two columns you are okay to choose?
Petal length and petal width.
Okay, petal length and petal width. Okay, so fine. So with this, you are not able to get the 100% classification, but at least it is better than the other two. Okay, because you can see the, I would say sepal width is the least important one. Agree, I can see more overlaps clearly. Fine. Sepal length is also fine, but it is still better than the sepal width. Okay, you can see a little spread out. Okay, these are the graphs are at least a little bit spread out from each other, but sepal width are like almost packed sort of thing. Okay, so if someone gives a sepal width, it will be extremely difficult for you to predict the type of flower, because anything you take here, there are chances for any of the three flowers. But here it is also there, but at least for okay, for some values over here, if it is something greater than 6, okay, if it is something greater than 6, you can say at least it is not belonging to setosa. Agree? If it is not belonging to setosa. Okay, here almost till the end you are having all the three. Okay, so if it is at least above 6, you can say, okay, it is not setosa. I don't know whether it is virginica or versicolor, but at least it is not setosa, you can say. Fine. So after that, you are having some overlapping. Okay, but sepal width is looks like mostly overlap. Petal length is helping much. Petal width is also helping much. Okay, so we are going to go by the petal length and what? Petal width. Okay, these two columns will help us. Okay, so did you guys understand? If at all, in case in future, so if you get any column, so you can just try to take that column, use the data frame and pass them as, you can just pass it as only one column. You can also pass one column and see some KDE plot, or you can also do with the output column. Usually you will have, if you are solving a classification problem, right? So you will have some output column. Put that output column as hue and give your input column as X, okay? And just plot it. So you will get this type of beautiful graphs. Okay, so this is like this, right? So for example, see, age. Okay, if your column is age, okay, if your column is age, and based upon the age, if the output column is your segregation, okay, that you are posting like constable, just as an example, constable or SI or DGP. Okay, so based upon the age column, then your age will be X column, and your this output column position, or what do you say? This is promotion. Okay, promotion will be your hue parameter. Okay, so then the graph it will give a beautiful graphs. Okay, it will say if age is bit lower, okay, that will be constable. If for somewhat age, it will be SI, and for the maximum age, you might be DGP. Okay, so if you want to divide this age based upon this output column, so use output column as hue and the input column as X, and it will give you the graphs. Okay, with these graphs you can understand most of the things. Okay, you can see just by, I don't know what are the values of this at all. Okay, I don't go through this data frame. Okay, but just by looking at the graph, I'm getting very good understanding, right? So what means what? So I can say that setosas are having very less, okay, starting values. Okay, I mean setosas are starting from the almost the least values are for the setosas. Okay, after that the Virginica are starting. Okay, and the maximum frequencies are observed in the setosa columns. Okay, because here the peaks are little less. Okay, here you can see maximum frequency, and it is setosa is also little densely distributed. That means what? The width is very much less. Okay, the width is a bit less. That means what? It is densely populated. That means what? If you understood yesterday's class, can someone tell me which particular parameter will, okay, will impact this width, guys? We have discussed one parameter which will impact this width of the distribution. Can someone recollect and tell me? I think yesterday Meghana and Karthik were there, right?
Standard deviation.
Yeah, perfect. So standard deviation, right? So standard deviation, that means what? You can also understand the standard deviation of this blue color, the setosa, and you can say the standard deviation is less. Why? Because here, if this is a mean, okay, if this is a mean, okay, the most of the values are located distributed around the mean. So that's why the distribution is densely packed. But if you see for the green color, the Virginica, it is bit more. Okay, it is bit more, and same thing for vertical color, it is bit more. Okay, so these details you are able to understand even though you did not look at the actual data. Okay, fine. So this is with the help of the PDF. Now coming to CDF, how you can use the CDF, right? So now here there is one point. Okay, for example, if I tell you, okay, if I tell you this particular point, okay, if I have 5, okay, in petal length equal to 5, what could be the output flower could be, guys? What are the possibilities? Petal length 5. Output flowers could be versicolor or virginica. Agree? Touching here, touching here. Okay, it could be versicolor or virginica. But now, if you want to decide, this is done, guys. Setosa is done. Leave about Setosa. Okay, this guy is a happy fellow. Put him aside. Okay. Now the fight is between versicolor and virginica. Now, if I want to understand, if someone gives you petal length equal to 5 and you are having both flowers, okay, but which one I should go with? Okay, which one I should go with? It could be versicolor also, it could be virginica also. Okay, how much confident you are? What is the percentage that it could belong to versicolor, or how much percentage it could belong to virginica, right? That you will get it from the CDF. Okay, that you will get it from the CDF. Okay, yesterday we have seen two things. We have also seen probability density function. Okay, this probability density function is just the KDE. Okay, which we have used this simple KDE plot. Okay, after that, at the end, we also saw the CDF, cumulative distribution function. Okay, and what I was concluded in the yesterday, if you just observe, I said integration of PDF will give you CDF and differentiation of CDF will give you PDF. Okay, this is just a recollection point. Okay, but the main point is For every graph, you can also have corresponding CDF graph. Okay. So now if you come over here, okay. So if you have plotted KD plots, simple PDF plots, that's fine. Now for the same plot, if you also want to plot CDF, okay, in SNS, you have something called as eCDF plot. Okay. You have eCDF plot. Okay. First of all, for the petal width, okay, for the petal width, if you plot where this petal width you have plotted this KD, right? So now along with this graph, okay, along with this graph, I'm also plotting eCDF plot also. Okay, same thing, petal width, variety, everything is same. So the graph will look like this, guys. Okay, the graph will look like this. So as you can see, petal width of setosa, versicolor, virginica. Okay, these are the PDF graphs or KD plots. These zigzag lines are there, right? Those are the CDF plots, guys. Those are the CDF plots. Okay. And it is important to observe. Okay. If you observe, what is the maximum value of CDF, guys? What is the maximum value of any CDF that is possible? 1. Agree? Why? Because for the maximum value, CDF will cover all the values less than that. And all the values less than that means what? Indirectly, it is covering all the data points. That means it is considering the complete probability. Fine. And maximum value of probability is 1. Fine. So that's why the maximum value of yesterday also I have shown you the maximum value of CDF will always be 1. Will always be 1. Okay. Will always be 1. And here also in the above graphs also in the day before yesterday's class, if you see the CDF plots, it will be always be 1. Okay. Even if you see some more CDF also, it will be always be 1. Agree? Here also, interestingly, here also, if you see now for the petal width, see the CDF. Okay. It is at the 1. Clear? All the CDF plots maximum value is 1. Okay. That's fine. But now try to understand, guys. So if at all I say this particular point, okay. So what is this? This value. Okay. Or this value, let's say this is 1.7, for example. Okay, 1.7. If it is 1.7, when petal width equal to 1.7, guys, when petal width equal to 1.7, what are the possible flowers? The possible flowers are 2. Versicolor and virginica. Agree? Because it is touching over here. Okay. There are 2 graphs, orange and also green. So 2 colors. It could be 2 possibility. So how to decide which output category it will belong to? Okay. So now for that, CDF graphs will help us. Okay. CDF graphs will help us. Okay. How? See here. If you see, you just okay, stretch this and see where it is touching this versicolor CDF plot. Okay, it is touching over here. And also, you see where it is touching. See, guys. Okay, this is our point. Okay, I just think that this is 1.7. Okay. Touching here. Touching here. Fine. Now, what could be this, guys? The maximum is 1. The maximum is 1. Okay. And what could be this point? A bit less than 1. 0.9. 0.9. Okay. And what could be this, guys? 0.1. This is 0.9. That means what? 90 percentage, 10 percentage. Getting, guys? Are you on track? So this particular point, 1.7, you cannot directly say which one it belong to. It could belong to versicolor or virginica. Okay. The next step is, if it is something between this value, directly you can say it's petal, it is setosa. No need to worry. But here you need to go one step ahead and use this graph. What is this graph? This is CDF graphs. Okay, this is exact. If you just extend this 1.7 point and see where it is touching the versicolor CDF, it is touching over here. And this value is 0.9. Okay, this value is 0.9. Fine. Now, what does this 0.9 means, guys? What does this 0.9 means? What is this graph actually we are looking at? This is what? This CDF graph. Okay, what is CDF? Cumulative density function. What does that mean? That means below this point, there is 90% of the probability to find a versicolor petal width. Do you agree? What does CDF tell? CDF will tell the probability, the cumulative probability to find out the values less than or below the given point. Agree? What is this saying here? What is this saying? Cumulative. So if I say one is what? If I say one, that means what? This one is 0.8. Okay. Yesterday we have seen, right? One is 0.8. That means what? The cumulative distribution function at 1, that means what? X is less than or equal to 1. X is less than or equal to 1. The probability to find a value less than or equal to 1 in this graph is 0.8. That's what we have discussed yesterday. Do you guys agree and remember these guys?
Yes, Santosh.
Yes, right? We also seen here it is 1. And this area could be, the area what you are getting is that is 0.8. Fine. That is the area what you are getting, this whole thing. The -3 to 1 is 0.8. Here also x is less than or equal to 1 means what? From -3 to 1, you are having 0.8. Similarly, here also, when you are seeing this, okay, when you are seeing this, it is touching here. It is 0.9. That means what? There is 90% probability. Okay. There is 90% probability, okay, to find a, what is this orange color, versicolor? Versicolor petal width. Okay, there is 90% probability to find a petal width below this value. Okay, so that means what? If you touch this value, okay, if you draw this value, okay, so below this value, okay, what is this value, guys? 1.7. Yeah, below 1.7, okay, below 1.7 or equal to 1.7, there is 90% chance it could be versicolor. Okay, but if you go down, where it is touching 10, okay, it is having only 10%. So over here, okay, till 1.7, okay, see this graph, the green color graph is still this point, okay, but we are focusing over here, and that is touching the green graph over here. That means 0.1, roughly 10%. So the CDF, the green color is what? CDF of Virginica. The CDF of Virginica is saying that there is only 10% chance. As of now, I have only 10% chance to argue saying that this particular value will belong to Virginica. Because this graph, the CDF graph is having only this much length, okay, which is 10%, which means that 10% of the values found below this, okay, 10% of the values found below this could be Virginica. Okay, it's not having much probability. If you touch here, if you take a value over here, some value over this here 2.1, okay, if you take some value over 2.1, okay, that will touch this graph over here. That means it is around 0.7. Okay, that means it is having 0.7 probability. Okay, it is having 0. That means 70% probability that this particular or 2.1 value could belong to Virginica. But if you extend the same thing, you don't see any other value overlapping. It is not touching this, it's not touching this. Okay, that means what? Maximum it will belong to Virginica only. Getting? But here for our 1.7 above you are having the orange color, which is having 90% probability, because if you see, it is covering most of the CDF. Okay, it's covering most of the CDF, and it is saying, hey, because, and also if you see this graph, guys, almost it is covered. Okay, here you are having 1.7. That means 90% of the probability that the given value could be belong to versicolor. Okay, but if you see the below point, just now the Virginica started. The graph is just this much only. Okay, it has just started, and here you are having 1.7. Okay, that means what? The CDF will also be only till this point. That's why if I draw till here, it is 0.1. Okay, that means what? If I drop this, and if it is in 0.1, 10%, it is saying I have only 10% of confidence that this particular value 1.7 will belong to Virginica petal width. Okay, because I have only some distributions to take the confidence. Okay, but above this, the versicolor is saying 90% confidence. Are you getting this? Is it clear?
Yes, Santosh. Understood.
Others? Oh, no? No, if you didn't understand, you can tell me, guys. That's fine. That's fine. You can tell me. See, it is simple. If you're having something value over here, guys, okay? If you're having, for example, over here, okay? See, over here, fine. So if you just need to extend that value, okay? Where it is touching over here. What is this value? Zigzag line, that is CDF line, okay? This line is how much? You just draw this 0.3, okay? So it is saying, it is saying roughly there is 30% of chance that this will belong to a versicolor. Okay, if you say just zero, what is this? This value could be 1.25. Okay, fine. So if you just tell me 1.25 is a petal width. Okay, based upon the CDF, okay, you will have 30% of the chance. Okay, that means what? In CDF it will tell you. CDF will tell you what? It will give you the probability. Okay, it will tell the probability that given value and all the less than given values could be found, okay, in the given distribution. So it is saying 30% is the probability for 1.25 or less than 1.25 to be present in the versicolor. Okay, I am focusing on 1.25. Okay, I want to take 1.25. So I will say 30% is a chance that the given 1.25 could be versicolor. Okay, but you're not having any other overlap. And also if you see here, if you take some point over here, so if you just extend over here, so it is having some 0.90% probability. Okay, if you say 2.4 is my petal width, okay, obviously it is 90% chance that it will become directly virginica, because, and it's also visible because your versicolor is ending here only. Okay, above that there is no versicolor. Okay, we are having only in this region there is only virginica. So that's why if you take any value, the CDF is not having any other overlap. So directly it is 90%. So it is mostly virginica. That's fine. But if you are taking some value over here, that is a problem, because it could be, there is overlap. It could be versicolor, it could be virginica. So that's what I'm doing. I'm just plotting this and putting over here, and above I'm getting it as 90%. Okay, that means 90% chance based upon the CDF that it could be belong to versicolor. But if you drop here, it is just 10%. 10% chance it could belong to virginica. Fine. From CDF, it is saying, okay, the CDF, this is CDF, okay, this is CDF, okay, it is saying 90%. So that's why based upon that, you can consider this flower could be versicolor. Is that clear? No? Okay. So I hope that's clear. Fine. So
Yes.
that, sorry.
Yeah, understand.
Okay, fine. So yeah, so that is a help, I would say usage of CDF and PDF. Okay. So with that, you can directly say, okay, similarly, you have some other CDFs also, okay, but this for sepal width, okay, this is, you can see bit overlapping part, okay, but for petal width, you can just by, you do not do any machine learning at all, okay, you not know any algorithm, but just by looking at the PDF graphs and just by looking at the CDF graphs, you are able to make some decent observations, okay. For Setosa, there is very clear segregation, okay, and for other graphs, you can also use a CDF formulas also, okay, and you can try to make some observations, okay. So I would say in future, whenever you are having a column, right? So any data set, you can just use the concept of KD plot, which is coming from where? Which is coming from probability density. And probability density function is related to continuous variable. Okay. So all these are chain related concepts. Okay. So that's why you need to understand what is a continuous variable. Then you will understand probability density function. And in that you have something called as KDE, kernel density estimation. Okay. And using that, and the and the funny thing is, even if you don't know any of these also, that is okay for you to, if you want to just plot, you can just use Seaborn and just do KDA plot, give the values, input value and the output column. You can get these graphs, okay? And just by, if it is any new other column, any other columns also, for example, we are seeing some basic Titanic plot, data set also. There also you can easily understand what is the behavior of different columns, what are PDFs, what are CDFs, and you can try to understand some of the details before doing any coding also, okay? So that is the importance of the graphs, I would say. Okay. So yeah, guys. So that's all. I think we have discussed much enough related to the basics of the distributions, right? So as I said, the PMFs we have discussed, PDF, CDFs. Okay, we have seen the practical implementation. I would say this should be enough as a good foundation for you to understand all the future classes. Okay, I hope you have now clear segregation in your mind. What is discrete, what is continuous, what is PMF, what is PDF, and inside this, what is CDF, and what does always CDF try to give you, what is the area. Okay, and also how you can graph plot those plots and to try to understand some basic things. Okay, so yeah, I think foundations should be good by this time. Okay, if not, go through the recordings again. Okay, so fine. So tomorrow we are going to study. Okay, actually today I thought of studying, but I just thought of showing you practical application so that you will have some better understanding. Okay, too much theory will also sometimes bore us. Okay, I understand that. Okay, but stats is like that. So stats will have some theory. Okay, but I think now we'll start seeing the code. So tomorrow we are going to see the code. Okay, tomorrow I'll show you a basic distribution called as uniform distribution, and we'll try to understand some code. Okay, and after that we are going to see, as I said, the fundamental the fundamental graph, the distribution in the statistics, which is called as normal distribution. Okay, and then you're going to see okay, and then you're going to see some interesting things about normal distribution. Yeah. Okay, guys. So that's all from my end. So from tomorrow, we are going to start from some actual practical distributions from this set of list. Okay. Yeah, I hope the class is clear. Okay. So try to go through the class again and have some understanding about these plots, guys. And you can let me know if there are any doubts. Okay. Fine. Are we good, guys?
Yes, Santosh. Once we'll go through the recording and if you have any doubt, we'll ask.
Yes. Yeah, I strongly recommend, because from today, so I'm going to stop the PDF and PMF discussions over here. So I think we have discussed enough. Okay, so there will be no more discussions on the basics of the PDF and PMF. Okay, because we have seen a lot of things. Okay, so make sure at least by today end of the day you have so you can watch my recordings at the rate of speed of 2, right? So while in class it might be slow, but in the YouTube you put the speed as 2 and complete the recordings and make sure you are understanding the concepts and make some notes. Fine. So then, so that you'll start understanding each individual distributions like uniform, normal. Okay. So fine, guys. That's all from my end. Thank you so much for joining.